You know that exact feeling, right? You're sitting there, staring at your screen, wondering why on earth your latest software build is just stuck, waiting in a queue. Do you go grab another coffee, stare at the ceiling? It is a universally shared frustration for developers and DevOps teams. You've written the code, you've pushed the commit, and then, bam, you hit a brick wall. Well, let's dive right in, because the secret to clearing that traffic jam is all about understanding your pipeline concurrency.
Welcome to the Explainer. Today, we're taking what might feel like dry, complex technical specs and turning them into a strategic playbook for streamlining your software delivery. We're going to look closely at Azure Pipelines, unpacking exactly how capacity is managed and how you can architect your workflows to actually move at the speed of your team's ideas.
Here is our roadmap for today. First, we'll be demystifying parallel jobs, then estimating your capacity, looking at the open source advantage, diving into infrastructure as code using YAML, and finally, enabling continuous integration.
All right, let's kick things off with Section 1, Demystifying Parallel Jobs. To truly optimize your DevOps environment, we absolutely have to establish that the fundamental currency of pipeline execution is concurrency. And the core rule of Azure Pipelines is actually beautifully simple. Parallel jobs represent the exact number of jobs your organization can run simultaneously. So if you only have one parallel job, only one pipeline job runs at a time, period. It literally doesn't matter if you trigger 20 builds. 19 of them are going to sit right there in a queue until that first one finishes and frees up its slot. Let's look at how this plays out in real life. Imagine a company, let's call them Fabricam Fiber. First, their CI build 102 on the main branch starts up, right? That consumes one parallel job. Next, release 11 is triggered. That eats up a second job. Now someone else tries to run build 101 on a feature branch, but because Fabricam Fiber only paid for 2 parallel jobs, build 101 is queued. It's stuck. But here is the really clever part. When release 11 has to pause to wait for a manual approval, it actually releases its parallel job back into the pool. Suddenly, build 101 can start. So it really acts exactly like lanes of traffic, being consumed, queued, and released in real time.
But hey, here's some good news. Not everything is going to drain your capacity. There are a few key exceptions. Like we just saw, jobs waiting for manual approval, they don't consume a parallel job. Neither do server jobs that run without agents or deployment group jobs. Knowing these exceptions is incredibly handy so you know exactly when your capacity isn't actually being used up.
Okay, moving right along to Section 2, Estimating Your Pipeline Capacity.
So now that we understand exactly where the bottleneck happens, let's get into the practical math of resourcing your DevOps highway so you're not constantly staring at queued builds. Here is a highly memorable takeaway for you. If you want a rough estimate of how much capacity you need, plan for one parallel job for every 4 to 5 users in your organization. So if you've got 20 developers actively committing code, you'll probably want to start with 4 or 5 parallel jobs just to keep things moving smoothly.
But of course, that 4 to 5 ratio is just your starting line. There are specific scenarios where your team is absolutely going to need to scale beyond that. For instance, if you have multiple active teams all running continuous integration or multiple branches with CI triggers just firing off constantly, your demand is going to skyrocket. Same goes for simultaneous application deployments, or if you have complex pipelines with multiple stages all trying to run in parallel.
And you've got to keep this massive gotcha in mind. Parallel jobs are a shared organizational resource. They do not belong to individual projects. There's no partitioning here. So if Project A decides to run a massive multi-stage pipeline, it will happily gobble up all the available parallel jobs in your organization, which means Project B is totally blocked until Project A finishes up. You are all swimming in the exact same pool.
Let's switch gears a bit. Section 3, the open source advantage.
Let's pivot away from the technical math and look at strategic project decisions. Microsoft heavily incentivizes open source development, and the impact this has on your capacity is just staggering. It's night and day. If you're running a private project on the free tier, you are limited to one parallel job capped at 1,800 minutes a month. But the second you make that repository a public project, boom, you are instantly granted 10 parallel jobs from Microsoft-hosted agents with completely unlimited minutes. It's a massive capacity upgrade just for developing out in the open.
But what does going public actually mean for your code? Well, it means anonymous users get to view your source code, your commits, branches, and pull requests. They can browse your dashboards, read your wikis, and search your work items. It's a real commitment to total transparency.
And this transparency, it completely changes the dynamic of community collaboration. Think about a popular open source library. Before public projects, a user might click a build failing badge and just hit a frustrating access denied error. Now, anyone can view the build results, figure out exactly why it failed, and proactively contribute a fix via a pull request. You're moving from isolated development to active collaborative debugging. It's a game changer.
All right, on to Section 4, Infrastructure as Code, using YAML. We've talked a lot about how much capacity you have. Now let's talk about how you configure the blueprints for those pipelines, and why we're moving away from manual visual designers. YAML pipelines represent the true infrastructure as code approach for CI/CD. Instead of clicking through a visual web interface and just hoping you remember which random checkboxes you ticked, you define your entire pipeline in a text file that lives right alongside your application's source code.
So why does Microsoft push YAML so hard for new pipelines? Well, especially in modern microservice architectures, creating pipelines manually through a UI is just tedious and honestly a recipe for disaster. With YAML, you get code reuse through shared templates. You get integrated version control, meaning your pipeline changes are reviewed exactly like your application code, and you guarantee setup consistency across dozens of different microservices.
The workflow for this is actually incredibly logical. You start by simply defining your pipeline steps in an Azure Pipelines.yml file. Then, you link Azure Pipelines to your Git repository. From then on, every single time you push code, your automated builds are triggered based on that exact blueprint. All that's left for you to do is monitor the results.
But here is where YAML literally saves the day: troubleshooting. When a build breaks, and you're using a UI designer, it's virtually impossible to know who changed what setting. But with YAML, every single modification is tracked in your Git version history. You can easily pinpoint exactly which pull request broke the pipeline, and more importantly, you can roll back that configuration change just like regular code. It is an absolute safety net for your team.
And finally, Section 5, Enabling Continuous Integration.
Look, everything we've discussed today, from managing your parallel jobs to writing these YAML blueprints, it all serves one ultimate goal: seamless, automated delivery. YAML pipelines are the absolute gold standard for validating pull requests and implementing true continuous integration. By mastering these configurations, you're ensuring that every single code change is automatically built, tested, and validated before it ever touches your main branch. You are literally taking human error entirely out of the deployment equation.
So, I'll leave you with this one vital question to think about. Are your pipelines actually built to scale, or are they just waiting in line? It is incredibly empowering to take full control of your DevOps infrastructure. I highly encourage you to go review your organization's parallel job usage today and take a really hard look at transitioning to YAML if you haven't already. Thanks so much for joining me on this explainer, and I will catch you on the next one.